All right. We are live. Hello, everybody. I hope everyone is doing well tonight. We are going to pick up where we left off on the last stream. We're getting a little bit of a late start tonight, unfortunately, but that's just the way things go. Things pop up in life sometimes, you know. But we're all good. We're ready to go tonight. So probably going to be a little bit of a shorter stream tonight as a result, but I think we're actually going to wind up deleting a bunch of code tonight, believe it or not. So before we jump into that, though, I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Olazaron, which is the highest tier of subscription over on Patreon, followed by our partners, Gobolis Inc. and Matt Oscard. That is the next tier of subscription there, followed by all the supporters you see listed here on the screen that are a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It helps a great deal with offsetting the costs of running this channel, things like software licenses, hosting fees, and eventually assets and whatnot, equipment costs, things like that. So it is very much appreciated and helps a lot. That being said, I would be remiss if I didn't mention a big thank you to all of the viewers, whether you're joining us here live on the YouTube side or the Twitch side. Thank you guys very much for being here. Without you guys, this would not exist. And of course, if you're catching the VOD after the fact, I appreciate you as well. All right, so with all that out of the way, we are going to try and get this file. At least we're going to work our way through as many of these errors as we can get. I have a suspicion a lot of these are going to be solved by deleting code. So we're going to see where we wind up on that. Etc. 4XG over on the YouTube side. How's it going? Good to see you. Spiro, of course, good to see you over on the YouTube side. All right. So what we need to do, I think probably the first and easiest thing to do is we had these sort of internal functions, function calls here that we wound up getting away from because we replaced them with the text require with options and options sync. Those are, for the most part, complete, so we're actually just going to take this guy and we are going to use the asynchronous version of that up here. So all that requires us to do is to go over here and just delete the word sync. And then we need to pass listener and callback. And I believe that's actually all we have to do for that. So that's the texture acquire, and then the texture acquire from package is going to be similar. So we're going to take that, and we're going to go here, drop that in here, and then again we'll drop the sync, and we'll say listener and callback. All right. And that resolves those. And then, of course, we'll have to sort out these other functions here as well, which I guess we could just go ahead and kind of fill out really quickly as well. So we have the acquire and acquire from package for cube maps, which is mostly going to be the same as this. So let's actually go ahead and take a copy of the acquire first, and we'll paste that right here. And the difference is going to be instead of the name just being based off of this, we're going to base it off this prefix, right? So this is going to be prefix for those two, and then oops, I actually forgot to grab this. So let's see. Right there. Okay. So that's the cube map. The only difference also that we'll need to do is change the texture type to cube. And I think that is all we have to actually do for cube maps, right? We don't actually have a function in here for arrayed textures, I just realized. And we don't actually have one to create from pixel data. So we'll actually need to create those API endpoints as well. Not a big deal. It's mostly just going to be kind of the same pattern of filling out one of these options structures and then just passing it through. So as we mentioned here, let's see, we need... okay, so these were the synchronous... Wait a minute. These were the synchronous versions of that. So this is the synchronous versions of... these are the async versions. Did we not create an async and a sync version of this? I guess we didn't. So we need to fix that, actually. That's actually a little bit more important. So we want to keep kind of with the same concept, right? So we have one with package and one with just the name, and then we have a sync and an async version of both of those. So this one we'll just call sync, and the same is going to be true here. And this is obviously going to be prefix and prefix, and then that should be all we need to do for those. These need to point to the asynchronous version, right? Which means our API here is actually a little bit wrong. So above here we did a void pointer listener and then a load callback, right? So we have the same thing to do here and here. Okay, and those are the asynchronous versions of it, right? So we have a prefix here and prefix there, and then this is going to call the async version, passing through listener and callback. Thank you for the follow. Appreciate that. Welcome. All right, which means we're actually going to have to head to the header file for a second and just update a couple of these things, because now these function signatures are actually wrong, which is not a huge deal. We'll go ahead and fix that. Texture system H. All right, so let's see. We have these guys. So we need to paste this here and that there. And I've actually kind of done that backwards, I guess. I probably should have taken a copy of these first. But we'll rename this to sync and rename this one to sync, and then do the same thing there. Okay. So now we have an async and a sync version of all of those. I'm actually just going to get rid of some of these comments here so that we can actually see. I guess we should probably reorder those too, right? Because these are ordered this way. So we have texture acquire sync, from package sync, then cube map versions of all of those. So we should probably make this match just so that it's all consistent. Looks like these do match. So I guess all we actually really need to do is just take this guy and move him up here. Okay. All right. I think that is going to cover it for those. So really just adding things like our array textures and stuff like that is really just going to be an extension of the work we've done here. I just actually realized that should be cube and that should be cube. Okay, so acquire from image. Acquire from image is actually going to just be a synchronous function call. Because that means that we already have the image loaded, and all we need to do is provide the pixel data, which the actual asset already has, right? So all we actually need to do is call this, right? So we'll do that. And here this will be a 2D texture. Let's see. Ooh, what do we use as the name? So asset image name is not needed. We need pixel array size is going to be image pixel array size. And then pixel data is going to be image pixels, right? So we don't have a name for this, because ordinarily when we load from an asset, we have a name. We get the name from the asset, right? The name of the asset that we loaded, but our assets here do not have a name, right? So if we do, image dot, right, we don't have a name in there. So we actually are going to have to provide a name. So let's do, I guess we'll do it this way, right? So there's that. Did we have that in the header file? I don't think that we actually did. No. Okay, so we need to do that. That is going to be a synchronous call. Let's see, auto release true. Okay, so actually, we should be able to just come in here and do, oh, I already had it right here. We also have acquire cube map from images, which we could use if we had cube map images already loaded. I'm going to hold off on that one for now because I don't think we're going to wind up actually using that one. I don't think it's all that valuable to use, at least for right now. So I'm going to hold off on that one, but I think this one is valuable to have, so we'll keep that one. Okay. So the only other thing I can think of that we need as far as an entry point is going to be for a layered image. But I'm going to say for the layered image, maybe we should just use, with options to actually do that. And then if we do that in a bunch of places, maybe we can add an API endpoint to simplify those calls later on. But for right now, I think we can just leave it to be done this way. I do want to go ahead, though, and provide an endpoint for pixel data and allow that, right? So this also needs name. So what we can do also is, I guess we'll do it here. So we'll do texture acquire from pixel data. And what we'll do here is we'll have a U32 pixel array size, a void pointer to pixels, and then also we should probably also have kpixel format so that we actually know how to interpret those pixels, right? So yeah, let's go ahead and implement that really quickly. So that is going to be almost exactly the same as this one. In fact, we're just going to do it this way. And this one's always going to be synchronous as well, because we're not dealing with asset loads, right? So it's always going to be a 2D texture. Oh, we don't have a name again. Oops. Right, let's use name. Okay, so 2D texture, name, auto release. And then this is going to just be pixel array size and pixels. Now, do we... I guess we pass format as just format. We may want to specify... We may want to specify like a source format and a target format in case we have to do a conversion. But for now, it's just going to be a straight pass-through. I think that'll be fine. If we need that, then maybe what we'll do is we'll have a separate function that does a conversion for us, and then we pass the converted format here, instead of actually relying on this API to sort of abstract that process for us. Let me catch up on chat. Is anyone else getting really quiet audio? Mike seems super quiet. I had to turn audio to 80% to hear. Is anyone having audio issues? Non-codes raiding with a party of 102. Holy crap. Thank you so much for the raid. How are you doing? What did you get up to on stream? We're just getting started over here. If you guys aren't following non-codes, definitely go follow her now. Much appreciated for the raid. Sound seems okay, okay. Maybe a bit quiet, okay. I'll have to see if I can up the output of the audio. Maybe I'll just get a little bit closer to the mic for now. Welcome, Raiders. I hope everybody is doing well. Saw some of your YouTube videos, very impressive stuff. I appreciate that, thank you. What are we working on? All right, perfect time for that question, actually. So, what we are doing, let me actually pull up website here, and I'll give a quick and dirty intro for the benefit of all the raiders so that you guys know what the heck we're doing here. What we are working on is something called the Kohi game engine. Thank you for the follows, by the way. And it is a game engine written from scratch in C, using Vulkan as its initial rendering backend. I say initial rendering backend because we support Vulkan for now. We have planned support for Metal as well as Direct 3D. It is cross-platform, so right now it currently runs on Windows, Linux, and macOS desktop platforms, with other platforms planned in the future. And so the idea behind this is that it's meant to be an educational resource, and it's a way to build a game engine, not necessarily the only way to build a game engine or always even the right way to build a game engine. It's a way. And the reason I say that is because we do a lot of experimentation on here and deep dives into things. And we try stuff out to see if it works. And then if it works, great. If it doesn't, we examine why it doesn't work. And go through that in detail. And so I believe that, stuff like this should be a little bit more widely available. And so that was sort of my motivation starting this. I'm hoping to increase the number of people that are looking to get into game engine development to drive competition, right? So if I can help inspire people to want to get into doing this, I think that that's a very good thing because competition drives ingenuity, right? So that is what we're doing and why. As far as the actual engine itself, just a little bit of background on that. So it started off as a YouTube tutorial series, but we quickly outgrew that format, as a project of any size naturally would. And so we changed formats a few times in the spirit of experimenting with things, ultimately landed on this live stream format. And so the website that I'm looking at here is kohiengine.com, so it's sort of the central hub for this whole thing. We've got links to YouTube, Twitch on there. We've got a Discord server link here with about 1,000 people on it. And of course, a GitHub link where you'll actually find the source. So if we take a look at this, the engine itself is completely open source and free. As I said, this is meant to be an educational resource, and I believe that that stuff should be free. So none of this stuff is paywalled whatsoever when it comes to the engine. The engine will always be open source and free. It is Apache 2.0 license, which means that you can use it for whatever you want, whether that be personal or commercial projects. It does not matter. The only thing that I ask is that if you use it, say you use it. That's literally it. There'll never be any sort of royalty or license fees or any sort of that stuff. I don't paywall anything. The only sponsors that I have are you guys through the Patreon and what stuff, and Twitch subscriptions and things of that nature. So like I said, that stuff's all completely optional, and is much appreciated, but not required. And so there's a little bit of a write-up here on the GitHub page about it. We've got some, albeit dated, screenshots here of the engine. So we've got a basic PBR pipeline with cascading shadow maps. We've started building sort of a little bit of an integrated editor where you can kind of click objects and move them around in the scene, manipulate them. We integrated both bitmap fonts and what we call system fonts, which uses TrueType fonts, and that includes UTF-8 characters. So we have UTF-8 character rendering for most languages, not quite all. I don't have right to left text working, and I also don't have some of the more complicated languages like Arabic that requires the little connectors. But all that stuff will come in the future, right? But the UI system is also written completely from scratch, right? And now what we're in the middle of is we're actually ramping up to make our first game with this, which is going to be a 3D isometric action RPG, which I'll actually show here in just a second. Oops. Let's see. Drag this down here. And so it's called Shadows of Illumina, and that is essentially our, at least the working title for the game. So we have, a little bit of a background for it. We've done a little bit of world building. I don't actually have the world map pulled up. Give me a second. I can actually pull that up too. One moment. While I'm pulling that up, we are basically ramping up the engine in order to be able to make this game. And so the idea is that the game itself is, like I said, an open world action RPG whose character progression is done via collecting items and stats. There's no levels, there's no experience, any of that kind of stuff. And so we have, lots of documentation here on things we want to develop, right? So I'm scrolling through it really fast because there's 29 pages of it, and it is consistently growing. We also have a little bit of a world map that we've sort of been building out as well. And so this is the beginnings of what some of the world is going to look like for that. And so we've got quite a bit of lore background already developed as well. So essentially what we're doing right now is we're identifying pain points with the engine that we've made in order to move that forward into a better direction to make it easier to use. So we're kind of refactoring some things to make things a little bit easier to use. That's what we're doing here, specifically with our texture system. And, it's going to be a little bit of a back and forth between the game code and the engine code because this is a brand new engine written from scratch. We are testing the engine by writing a game in it, which we are going to take all the way to release, and we're going to release it on Steam when it is done. So yeah, I guess that's not so quick or whatnot, but yeah, that is that's the gist. Again, thank you so much for the raid. Go and enjoy your dinner. It's much appreciated. And welcome, raiders. Let me catch up. I like everything pure C. Yes, the whole thing is written in C with the exception of a few minor utilities. We have some bash scripts, a couple bash scripts, a makefile, things like that. But we are actually going to write some point soon. We're going to write our own build system in C as well, similar to like Soding's no build is kind of what that's inspired by. So we're going to have a build system for C written in C, but it's going to be tailored to our project. So we'll be able to get rid of a lot of those dependencies as well. Apotham, how's it going? Good to see you. Welcome. Knob mentioned. Yep. Yeah, exactly. So yeah, that's kind of something I've been wanting to do for a while, and I think it fits the theme of this very well. We try to avoid using external libraries, and we roll everything from scratch here as much as possible. There are a couple things that we did take a minor shortcut on, but those things are effectively asset imports is really the only place that we've done that. And that's for image decoding and font file decoding, as well as things like MP3 file decoding, things of that nature, right? But aside from that, there are no dependencies. Those are all actually included in the repo along with it. Seeing you over on the YouTube side, how's it going? Good to see you. Welcome back. All right, so like I mentioned, what we're doing right now is we're actually stepping through our texture system, and we're redefining our API to make it a lot easier to use. Because previously, what we did was we sort of went through this this resource system where you had to set up sort of a request object that told you, you know, what assets you needed and various information about what type of resource you were going to request and things like that. And then it just sort of reached through all these various different systems to sort of get what it needed. And we're reducing the complexity of that. So in this stream, we're actually converting over to a simpler way of doing it, and then we're actually going to nuke a bunch of code as well. So I'm hoping I actually get to that before the end of the stream, but that is kind of where you guys popped in. So I hope all of that makes sense. This is an interactive stream though, so if you guys have questions or whatnot, I do keep an eye on chat. It may take me a couple minutes to get to it, but yeah, if you guys do have questions or just want to say hi or chat, I do keep an eye on that. Okay, texture acquire from pixel data. So this is basically just a pass through like the other ones to acquire with options sync. So that is that one. This one, acquire cube map from images, we're not going to do right now. I'm just going to tag that with a to do. We'll come back to it later. Okay, so let's see. Okay, so we had the acquire with options async. Oh, that's right. We left off on handling pixel data. Okay, so this didn't we actually have in our synchronous version? I think we already handled this. I believe that was essentially this bit. I'm actually going to copy this for now. And we're going to come up here and we're going to handle pixel data. So pixel data is, to give a little bit of scope, this acquire with options is basically what all of our other API points pipe into. And so we have a synchronous version of that and an asynchronous version of that. And it's asynchronous because our asset system has both a synchronous and an asynchronous call. Typically, loading assets is, you know, it can be a fairly slow operation reading that from disk. And so we have this asynchronous process which allows us to basically toss that off onto a different thread to be handled separately. And so we can continue doing other work while those assets are being loaded. And so we have the ability to do that, but we also have the ability to load assets synchronously. And that would be for something where we need that right away because our code is very linear and requires it right away. And we're going to have situations where we're definitely going to want that. Things like loading application config or something else, you know, something core that requires that a lot of other systems depend on or something like that. And so essentially the way that we have it here is our functions for this anyways, the asynchronous version is just kind of named like it is. And then the synchronous version has underscore sync at the end. So if there's no underscore sync, then that's considered to be asynchronous if there's both versions of the function. Otherwise, it's asynchronous. And so the context for that here is this acquire with options. Essentially, the way that this works is it only actually has to be asynchronous if we're actually loading assets. And there's a couple of different reasons why we may or may not want to do that. So, thank you for the follow, by the way. So, when we are filling out this options structure, which looks like this guy, right? So it's this. We can provide either a single image asset name and or a package name, right, to load from a specific package. Or we can specify a set of asset names if we're loading multiple images into a layered sort of texture. Or we can actually provide raw pixel data. So if we generate image data in code, which we actually do in a couple of places in our texture system, we can provide pixel data. So if we're loading assets, then the asynchronous version needs to actually run asynchronously. If we are not loading assets, meaning we are either creating like a writable image to render to, for example, where we don't have any data to upload to it, it's used for something else that we dynamically generate. Or if we have pixel data that's already in memory, then there's no need to maintain the sort of asynchronous nature of it. And so we can actually handle that inline. And so that is sort of the context on there. So what this does essentially for now is if we have image assets, right, we actually set up a listener structure that has all of the information about the image assets, a user listener and callback, which would have been provided when the function was called. We have the listener here and the callback here. Other things like what the name of it is, the various options themselves, a array of assets, and so forth. And so essentially what we do is we fetch the assets either directly from a package if we have a package name, or from the default application package if we don't specify one. And so what this does is it then eventually forwards on to this function, kTexture, texture kAsset image loaded. And this guy actually, and we have some fix me's and some stuff to do in here, right? But this guy actually does what we call apply asset data, right? And so apply asset data is called from a couple of different places, but the meat and potatoes of it, so to speak, are we actually request or acquire texture resources from the GPU. So that means like the amount of memory, texture handles, or image handles as Vulkan calls them under the hood, those kind of things, right? We actually perform those allocations against the actual GPU hardware. And then we perform a combination of asset pixel data if it's needed. And then we go ahead and we write that texture data. So we actually only need a couple parts of this if we are dealing directly with pixel data. So what we actually need here is basically this section. So we can come back here to our acquire with options. And I think that's actually basically what I had here. Let's see. Pixel has transparency, write data. Did we acquire the data? I don't think we did. So let me just go ahead and paste this in here, and then we will take care of this. Okay. Obviously, our go-to statements will have to be updated with the correct labels, but let's see. Didn't we already do a... No, we have not. So this is going to be options, pixel array size. Oops, actually it's just pixels. Pixels. Pixel data. Options, pixel array size. And then, let's see. We have We have texture format, which would already have been set up here. MIP levels would have already been set up. So we go ahead and set the transparency flag. And then actually we need to do a check on this actually. Because all of this revolves around options pixel data and options pixel data array size. Because it's possible that neither one of those things are true, right? So we only actually want to do all of this stuff if we actually have pixel data that was provided as part of the options, right? So let's see, write data. This is going to be, again, options, array size, options, pixel data. So this is what actually uploads to the GPU. I think we can actually, in this case, since we are setting pixel data, I think we can assume this is still going to always be 0, but I'm going to keep it separate just to be explicit. We've already done this. And then we've already done this as well. And this, actually, let's use this one. And then we'll go up here, change our label. Handle pixel data if provided. All right. Okay. So in this case, we do not have all pixels. We do not have, well, I guess we do have image asset names, right? Or did we? Yeah, we potentially have those. Okay, so we do need those. All right, so essentially the way that this works, and I know some of you are going, ooh, goto, why are we doing that? Goto is extremely useful in cases like this, where we have multiple failure points in the same function. So let me just fix this guy really quickly. So our failure code is, you can think of it, if you're used to using try catch finally, you can think of this as kind of a finally, right? So everything after this label is essentially our finally section of code. You can think of it that way, right? And so no matter what we do, if we have a texture and we have these image asset names, which actually, if we have these guys, we need to clean up those arrays, right? Those are dynamically allocated arrays, potentially, if this operation is successful. So if we have those, we need to clean them up so that we don't leak memory, right? If we were not successful, we need to do a texture cleanup, which basically undoes all the operations that we've done above and frees any resources, right? And then sets our texture pointer to 0 before returning. So this goto is basically like the point that we jump to. Either we naturally flow to it or we jump to it in an error, right? And this is a primary case of where you want to use a goto statement. So essentially what we do is all the way at the top, I missed another label. Let's see. Why is that bleating? Undeclared label. Did I? What? I think my LSP might be tripping. All right. All the way at the top of the function, before we do anything, we say success is equals false, right? So this is our sort of default case, if you will. And the only place that success is ever set to true is if we naturally proceed through all of this code without any errors or anything. Right before we actually get to this label, we set true to success, right? And so when we jump here, the only way that this success could have been flipped to true is if we naturally got there. And so this will automatically clean up the things that needs to be cleaned. And then if not successful, it'll clean up the texture itself. Otherwise it won't. And so we do this to avoid having to either externalize all of this to a function, which would be dumb, or what would be even more dumb would be repeating that code all over the place and then returning early, right? So this is just a much cleaner way to be able to work, than doing either of those other two options. And this is something that is a lot of people say go to, don't ever use it. I say use it sparingly. Use the tool exists for a reason. Use it properly. It's really easy to sort of use it wrong and shoot yourself in the foot with it, and that's why people say don't use it. But I think that's rubbish. The tool exists for a reason. So yeah, this is real clean code. Despite goto is claimed as harmful by Uncle Bob. Yeah, and I disagree with almost everything he says. Yeah, for a reason. And Casey Muratori went into great depth on a lot of that stuff, right? But like, this is another example where they say, they talk best practices and you should do this and you shouldn't do that. Well, what about the scenarios like this where it's perfectly valid and makes sense to actually do it? Nothing wrong with dirty code, in many cases easier to read. Yeah, I mean, and clean is subjective anyways, right? Because what's clean to one person is going to be absolute garbage to another person. One person's trash is another's treasure and all that. So it's clean is very subjective and frankly it's emotions based as opposed to problem based or reasoning based or data based. And coding based off of emotion is not going to get you very far. It tends to lead to a lot of problems we see in code bases that you see out there, that are super slow and bloated and out of control. Holy crap, clean is emotions based. Never thought about it this way. Banger statement. Yeah, I mean, it's true though, right? Different scenarios require different tools. Exactly. Use the right tool for the job, right? And this is the right tool for this job. So I usually have to preface that because I almost always like, especially when we have new folks come in, a lot of people go, what the heck are you using goto for? So pardon the side discussion there, but that's what that's all about. Okay. So this is how we handle pixel data if provided. So we do an acquisition. Actually, there is one more case we need to handle. So this texture resources acquire actually can happen in one more spot. And that is the other case that I talked about. So when we're loading up a texture, we can either have asset image assets that we need to load. We can have raw pixel data that's provided, or we can have neither, right? So in that case, we should probably, if we have image asset names, we boot out early, right? And that just goes to this asynchronous call and ultimately lands in this callback here or here. And that's pretty much it, right? So if we go here, that's our code path there. Otherwise, we are going to say we need to check for options pixel data or options pixel data array size. So we could very easily say, how do I want to do this? Let's do this a little bit differently. Let's do, I know, a Boolean, but let's say has pixel data equals this, right? So has pixel data we'll do here. Now, either way, we will have a width and a height. right? Which should be provided in our options. Ooh, I just realized something though. We did not provide that here. This API endpoint does not have that, and it needs to. It must, because otherwise, how are we going to know? So U32 width, U32 height, right? And then we can do width equals width, dot height equals height. And then, of course, we need to go to the header file and update that. So U32 width, U32 height. If I could spell it correctly, that'd be awesome. Okay, so we need to specify the width and height when we have pixel data, right? So actually, we should probably do, if not width or not height. And we'll say function name requires a non-zero width and height. You dingus. And we'll just do function, right? And we'll return no pointer, right? We cannot proceed if we don't have that. Okay. So when we come down here, we say it has pixel data. Now, whether or not we have pixel data, this statement needs to actually happen. So actually, the way that I was thinking about doing it actually doesn't even really need to doesn't really need to do anything. We don't need this. I was going to split it up differently, but I can just keep it that way. All right. So we need to get the texture resources either way, even if we don't have pixel data. We still need to request that even if we're not uploading pixel data. If we do have pixel data, then we check for transparency and set the flag appropriately. We can assume, because I don't think we have, we don't have has transparency as an option, and I don't think we really need it, right? Generally speaking, if we're creating a writable texture, it's generally not going to be needed, and if it is, we can set it in the flags manually. Okay, so we only do this check if we have pixel data to check against. We only perform the upload data if we have pixel data, and then we obviously only check the write result if we have pixel data. So that actually just automatically handles the no data case, right? Without us actually having to specify that. Okay, cool. So that actually covers the last case. Let's see. Primogen said he can go only 4 levels deep before he forgets what he was looking at. It's not quite that limited for me, because I've had to architect some pretty deep systems for like work-related stuff that are way more layers than that. But yeah, I get it. Goto takes me back to programming with my TI-99. Yes, actually, this came up on the last stream too. So the first programming language I ever messed with was QBasic back in the day, and it had a goto statement. And in that case, you would do, goto and then the line number of the actual program. So yeah, that takes me back for sure. No, it's probably way too early, but how do you test your code at this point before you go too far? So, everything we're doing here in terms of like loading assets and conversion of formats and stuff, all was previously working. What we're doing here is we are sort of moving stuff around a little bit. So essentially what I'm doing here is when we are done refactoring this texture system, we're going to obviously have to change the function calls of everything that points to it. And then we will actually just run, we'll run the game project to see if that works. The game project and thus the engine itself actually exercises most of these entry points by default anyways. We have the texture system has a series of default textures that get created. And those default textures are a series of different options in this actual options structure. And so automatically, just because of the way that that's set up, this particular system is already kind of tested. As long as like we load up and everything just sort of works right off the bat when we go to launch this, it'll work. But yeah, this particular change set is going to be a little bit large because the texture system is used in so many other different systems throughout the engine rather. Which is one of the reasons I chose to do it first, because it's the most complicated and the most wide-reaching. And then the other asset types will be, should I say, increasingly smaller or decreasingly smaller? Smaller as we continue, right? So, yeah. First one was Pascal. I remember writing Turbo Pascal in middle school. Borland Turbo Pascal. I forget what version. I want to say 6, but I don't know if that's correct. It was back in the day. I might be wrong on the version number there, but yeah, it was Borland Turbo Pascal is what I used to use also. That came after QBasic. I completely forgot about that, actually. Okay, so I think that solves all this. I still don't understand why it's having problems finding this label. Oh, this is the first instance of it. Did we actually... What did I call? Is this actually different than the one down here? It might be. Did I do... I did. Oh, this is async. There's an example of some dingus-oriented programming for you. This should be async. Which means all of these guys should be async. Let's see. All right. I think, let me check this. Yeah. So for a little bit of information on what dingus-oriented programming is, I actually put a command in there called dingus for the old chatbot. So dingus-oriented programming is basically where I make a stupid mistake on screen. And it's usually, something small and something stupid, but which is just kind of a term that got coined on the stream. And, if it's severe enough, I just kind of toss one of these in here. But yeah, that's dingus is inevitable. Yeah, absolutely. I do dingus-oriented programming on here all the time. All right. So we have that. Let's move on to some of the other errors. This is all under old remove, which is sweet, because I think this is actually where we get to start deleting crap. So that function can definitely go. That one can definitely go. We've got all the logic we need out of that. Cube writable, that can go. We don't need that. Same with depth. In fact, it's going to be the same with most of this stuff. We can actually get rid of... Let's see. all of that. Texture system release resource. I believe we already have texture release right here. So we don't need this either. Texture system resize. Okay, so this is something. So this is an old function where we actually have to resize a texture, right? So this we actually are going to have to. We are going to have to handle this one. So I'm going to actually just take this and just refactor it. Right, so we used to have this old structure called kResourceTexture. Now it's just kTexture. And instead of texture system resize, it's just texture resize. And I don't know, I don't think we've done the header file version of this. So let's go ahead and snag that in here real quick. So we'll export that. Regenerate internal data. Yeah, I guess we need that. We need width, we need height. That's going to be the new width and the new height. And then, of course, the pointer to the texture. Okay, so all of those things can remain the same. We want, this should be kTexture flag is writable. So if the texture that we've created is flagged as writable, then we can go ahead and resize it. If it's not considered a writable texture, then we don't want to allow it. We want to warn about this and return false. Because there's really no reason we should be resizing non-writable textures, right? Let's see, what do we have in here? Remove this requirement and potentially regenerate internal data flag as well. Only allow this for writable textures that are not wrapped. So let's talk about wrapped textures for a second, right? Because I think that still is very much a thing. Let me see, though. Do we actually... We do actually use that. Okay. But we don't actually use it at the texture level. It looks like it's completely internal in the Vulkan renderer. Okay. I'll keep it for now. But we do need to eventually address this. So, what is a wrap texture? So, the way that our texture system works, and textures in general for this engine, is we have, I guess I should back up and explain. We have a renderer, what I call a renderer front end, and a renderer back end. So the renderer front end is sort of the platform and rendering API agnostic code, right? So that's all of the logic that faces the engine and thus the application that is not specific to Vulkan or DirectX or Metal or any of that stuff. In fact, it's none of that stuff is exposed, right? That's why we call it the renderer front end. So it's what the engine and the application, if need be, interface with directly. Then we have the renderer backend, which is actually implemented via our plugin system that we have, because the renderer backends can be activated or deactivated via a plugin system. And each one of them is indeed a plugin. And so that is where all of the render API specific code exists. So we have a Vulkan renderer plugin, and that's where all of the Vulkan code lives, right? And so this texture is wrapped, has to do with the internal representation or the API specific representation of the texture when it comes to the actual GPU, right? So in this case, a Vulkan image and the memory and other stuff associated with that, right? So the renderer backend has its own internal lookup table for textures and the internal resources associated with those textures. And those are mapped to the front end texture, which is ultimately this K texture, via a handle. And we have here something called a K handle, which is the renderer texture handle, right? So this is a handle to that backend resource, right? And again, the front end knows nothing about the resource on the back end other than the fact that it exists and has a handle to it. And so anytime we do anything with textures, we always go through the front end and we say, we want to do something with this texture. Here's the handle to the backend texture, and then that goes through the renderer. The renderer reaches out to the backend, the renderer backend, and does what it needs to with that texture internally. And so, obviously, the reason we have that is so that we can have multiple rendering backends, and we don't have to have the engine code worry about it, and so forth. So, what is a wrapped texture then? Well, a wrapped texture is a K texture or a front end texture that has been created around a back end texture that was created via some back end specific process that is not owned by the front end texture. So, what do I mean by that? We have the normal process of creating a texture is you say, I want a texture from the texture system. It creates the front end resources. It tells the back end, I need a handle to a new texture and create the texture. Give me the handle, the back end resources for that. So the internal memory block, the image, all that stuff. And so Vulkan does its thing. All of that process returns. We get a handle back, and we're good. That's the normal process of creation. A wrapped texture is created a little bit differently. And the example I always use for this is the swap chain textures. This is specifically what this was created for. So the swap chain texture is what we consider a wrapped texture. So whenever we create the swap chain to render to a window, that swap chain owns the images that are associated with it, right? So the swap chain creation also creates those images. Those images are owned by the swap chain. So we can't just destroy them, because if we try to destroy them without destroying the swap chain, that's going to cause problems, right? So the swap chain owns that. We don't have a way to say, I need to create these textures from the front end, nor should we be doing that, right? And so if we need a front end reference to that texture, which we've actually mostly eliminated at this point, this is how we would do it. We would say, I have a back-end texture resource that I need to be wrapped in a front-end texture. And that's what the concept of wrapping is in this case, right? And so the way that this used to work was we used to render all of our stuff directly to those swap chain images. And so we needed a reference to those images on the front end. We've since switched away from that, and now we actually create writable textures on the front end that we render to, and then we take the contents of those textures and blit them to the swap chain images within the Vulkan layer. So we don't actually need this any longer, but I haven't completely removed it yet because I'm not 100% sure that we won't need it in the future. But for the Vulkan layer, we don't need it. So that's what this is all about when it comes to wrapped textures. I hope that makes sense. And so that is what we are talking about there. Okay, so whenever we are checking, doing checks other than making sure it's writable, we set the new width and height, right? We do a check on the flags to say, is this texture wrapped? We want to make sure that it's not a wrapped texture, because if it's not a wrapped texture, we don't own it and we shouldn't be resizing it. When we say render texture resize, that internally passes a message over to Vulkan to say, I need this texture resized. Here's the new width and height, which essentially creates a new image resource under that same handle that already exists for that texture. If it's a wrapped texture, we do not own that texture, so we should not be doing that. And so essentially, if we say texture resize and it's a wrapped texture, it's essentially a no-op at this point. All we do is update the front end width and height, but the back end texture does not get a resize because we don't own it, right? And so only if we have a non-wrapped texture and we say regenerate internal data, which I'm thinking we might be able to actually get rid of as well, then we say render, go ahead and resize it, right? And then we also have this increment generation here, which is something that I don't think we need anymore, because I don't believe Yeah, we got rid of generation. We don't need it. So actually, we can just do return that, right? And then we're done. So if it happens to be a wrap texture, or we say we don't want to regenerate the internal data, then we return true because it's technically not a failure. It's just a no-op, right? And then obviously, if we don't have a texture handle passed, then we need to return false. We should probably also say if not width or not height, then k error, spit out the name of the function, a non-zero width and height are required. Right, and we'll do function and return false, because that is actually a failure. Okay, so that's texture resize. I believe we have that on the front end already. We already did that. All right, so that's good. All right, let's see. Texture system write data. So this is probably something we should keep too. This is essentially writing pixel data, right? And we have an offset and a size. So if we wanted to, we can write to a specific part of that pixel array. So we probably, I guess we could keep this and just convert it to use the new structure. So we'll do that. And actually, I think that's just all that's going to be required for that one. So let's go here and export that and go back. All right, return text or no, let's see. I don't know if we're actually going to need this or not. I'm going to hold on to this for now. I don't know that we're going to need it, but I'm going to hold on to it for now. Very fun and informative to watch, but I have to bounce. No more dingus, please. I got it. Yep. No worries. Check the repo in spare time. Awesome. Yep, I appreciate you being here. Can't guarantee no dingus-oriented programming, though. Let's see. The world is unrecognizable. The world is unrecognizable. What do you mean by that, Adam? Over on YouTube? You're talking about this world? The world of Illumina? You know what I mean? Yeah, I think I do. I think I do. All right. I guess, let's see. Is default texture... We should probably keep this one too. This is just a check to see if the texture pointed to here is one of the default textures, right? So we should probably keep this guy. Oh, this should be texture write data. And then let's do texture is default. Let's make that a little bit more consistent, right? Right, so this was texture write data. And then I think we actually have, yeah, we have some of the comments here, right? So I'm actually just going to take these and go up here. and paste these here for a hot second. All right, so resize goes here. And then rate data goes here. And then we can get rid of these. Okay, pointer to the texture to be resized. Okay, so these comments are still true for these ones. Okay. Audio Tour, how's it going over there? Good to see you. It's not the 80s anymore. Yeah, no kidding. Yeah, you're not wrong, Adam. Tetriarch, how's it going? I am doing well. Thank you for asking. How are you doing? Hope you're doing well. Just cleaning up some code and actually deleting stuff, which is cool. All right, so texture is default. I wonder if we should. Maybe get rid of that. Yeah, oh, it's static. It's internal. I guess that's fine. Create default texture. Okay, so here is our creation of default texture. So remember when I was saying that we have creation of default textures that exists that already has like all the pixel data and all that other stuff. This is where all that's done. So we create a number of default textures, each of which have their own sort of different reasons for creation, right? Or their own different uses. And so those default textures are here. Like we have just a default texture in general, which is just like a checkerboard texture. Default base color is a white texture. Default specular texture is a white texture. Default normal texture is actually blue, because that's, Z up basically. MRA is metallic roughness and ambient occlusion. So that's a texture that we actually build that gives you a default, reasonable default for that. A default cube map, and then sort of the default water normal and DUDV textures for water, right? And so all of these have, their own specific uses, but that's essentially what we mean when we say default texture. So all of these, except these last two, are actually created in code. And these two technically come from assets, but I might eventually encode their data into the code so that we don't have, on-disk dependencies for engine-specific stuff. Let's see. Wrapping stuff up, doing research before transitioning from Windows over to Linux. Nice. What distro are you thinking of going with? I know a lot of people have been talking about Arch lately, which is what I'm using here, by the way. Because Arch, by the way. But yeah, if you're new to it, it might not be the best thing. But if you have some experience, I would say try it. Unless you've got something different in mind. All right. Okay, so create default resource texture. So this is what our old system required to get a texture, which is why I'm saying we're doing away with all that, right? Because there's no reason we should have to be doing all this stuff, right? We could just very easily provide pixel data and like format data and stuff like that and have everything that we need, right? We don't actually have to do like all of this stuff, right? I'm going to keep this for now, but it is going to wind up going bye-bye. So create default textures is definitely a function we need to keep because that is an internal one that we need, right? So I'm going to move this up here above our remove to do. So essentially each one of these we create just a pixel array. In this case, all these are pretty small, so we just do it on the stack. Do a mem set on their data, and then we set some of the pixels manually just to kind of get whatever pattern it is that we're looking for, right? So here is the default texture. And so this is create default resource texture. So what we're actually going to want to do here is we're going to want to use our texture acquire from pixel data, right? And so the format we're going to want to use is kpixel format RGBA 8, right? The pixel array size, right, is just going to be pixel array size. And then we have a pixels array, so we just use pixels. Oops. Thank you for the follow. Painzen, how's it going? Long time no see. Yeah, it has been a minute. Let's see. Ran Mint for a year or so in the past. I'm considering Arch or anything Arch-based. I remember issues getting up-to-date software when I was on Mint. Yeah, so anything that is Debian-based, right? So there's pros and cons to that, right? So anything that's Debian-based is going to be stable, but it's stable because the packages are old, right? Which is the reason I stopped using it, because getting up-to-date software on it was kind of a pain in the butt. And truthfully, I have had to reinstall my Arch install twice, and both times it was my fault, right? So any issues that I've run into, I've never actually run into an issue that was like so dire that I had to jump to another distro. Like, it's just, I know a lot of people say that they break their config all the time, but it's like, if you don't install a bunch of crazy stuff, you're not going to have to worry about it. At least that's been my experience. And I say this running, I'm currently running KDE Wayland on an NVIDIA card, which if you know anything about setting that up, that's usually like, in the past, that was a big no-no. But yeah, it's been working great for me. Falonier, how's it going? Welcome. For those of you who don't know Falonier, definitely give him a follow. I'm going to give you a shout out. There we go. I am doing really well. Glad to have you here. Welcome. He is the team lead of the group that you see under my name there. So definitely give Falonier some love for sure. Let's see, I have an AMD GPU and CPU, so I should be golden in that regard. Okay, even better. Yep. Yeah, I actually have a separate machine here that has that set up, and it's been fine there as well. Fedora is a good balance between up to date and stable. So I have not used Fedora in 15 years. I want to say it's been about that long, so I can't really speak to that one. I have been thinking about giving it a whirl, but yeah. Internal static void, how's it going? Good to see you. Let's see. Because Arch, by the way. Yeah, exactly. You have Kubuntu. I gave that one a whirl as well. Kubuntu is pretty good. I use that one. And Windows 11 dual boot. New PC coming Friday. Oh, congrats. Awesome. Yeah, so I actually dual boot, right? Because like this engine project requires that I support Windows. So I actually dual boot on this machine. I've got Windows 11 on a different drive. But I daily drive Arch. I only sign on to Windows when I either have to or by accident. Let's see. Okay, so width for this guy is going to be 16. Height is also going to be 16. And then the name, let's see, did we? Oh, default texture name. There we go. Boom. All right, so that is going to be... That's going to be our default texture, right? And so essentially we switch from having to call this function, which does all this other crap, down here, right? We don't have to do that stuff anymore. Now it's just a single function call, which is a heck of a lot easier to use, I think. Oh, got some redeems. Let's see, stretch. Yeah, I could use a stretch actually. Oh, my elbow just popped in like three places somehow. That's cool. Thank you for the redeems, Nick Deli. Posture check. I'm kind of actually doing that now, as well. But yeah, I think my posture was rubbish because now my back hurts. And there's the hydrate redeem. So thank you for those. I'll be real, I used to daily drive Linux, and I did the thing where I have a Windows virtual machine with GPU pass-through and all that craziness. Yeah, it is fun. For my purpose, WSL Hyper-V fill all my Linux needs. That's fair enough. If you're running anything graphics accelerated, though, that gets a little bit awkward. But you're an unironic Windows 11 fan. I mean, to each their own, right? Use whatever you're comfortable with. I'm not one of those guys that goes, oh, you should never use Windows. I don't want to use Windows unless I have to, right? It's not my preference, but if you're using Windows, use whatever. Use whatever you're comfortable with. WSL supports GPU acceleration? Oh, does it? Okay. Granted, I've not tried that in a number of years either. I kind of, since I got this dual boot setup working, I just haven't had a need for WSL, quite frankly. Many cases better than actual Linux. That would be interesting. Because I have some games that actually run faster on this than they do on Windows. Biggest issue with Linux is lack of a good debugger. So I do use the editor that shall not be named. So I do actually use this guy as my debugger, right? And I don't like it for an editor, obviously. I use NeoVim, right? But this is the best cross-platform developer out there on the market right now. I am closely watching Rad Debugger because I eventually want to give that a shot because that is looking really good, but it's Windows only right now. I know he's currently working on getting it to work on Linux, right? But and I don't know if he's going to ever work on getting it ported to Mac is the only other thing. But I do eventually also need to, as Internal Static Void has said, I need to pick up GDB at some point and try that. Do I have my NeoVim config open sourced? I do, actually. If you do !NeoVim, I'll do this on the YouTube side as well. So that's an article on my website about everything that I use with NeoVim and why. And then it actually has a link to my NeoVim config. It might be slightly out of date at this point, but if it is, it's only like minor things. Lack of a good debugger. Well, I mean, GDB is like the GigaChad developer debugger, right? It's probably the best there is out there. It powers this one, right? I just don't know it well enough to use it. Tried raw GDB and didn't find it very practical. Yeah, and I mean, I have a feeling that I initially found the same thing when I tried it, but I also think that's a user issue, right? Because I didn't give it like a couple months of using it to try and get it right. That was kind of the same thing where I was bouncing back and forth between Vim for a while and other stuff. And then once I actually sat down and said, you know what, no, I'm not going to use anything but this until I get good with it, and then actually give it an actual chance. And then once I got good with this, I'm just like, I don't want to use any other editor at some point. And I suspect it may be the same thing for GDB. Recently been into just configuring NeoVim rather than learning. Fair enough. Yeah. Fair enough. I get that. Let's see. I think this actually is going to wind up being pretty much the same call, except we're going to have pixel array size and then diff pixels. And then default base color texture name. And it's still a 16 by 16 texture, so that's all we got to do for that one. This one, the specular texture is going to be pretty much the same deal again. This is going to be just change the name. Let's see, pixel array size. How did I not have... Oh, it's down here. There we go. And then we need spec pixels. All right, and then this is going to be... Wait a minute, what did I do here? Did I paste it twice? All right, we just rename this. There we go. Okay. So that's the default specular texture. I think most of these are going to wind up being the same thing, except for the cube map texture at the end. So these are all 16 by 16 textures. Nice and easy stuff. This is going to be normal pixels instead. And then it's going to be default normal texture name. All right. Oh, the MRA texture. So that's the combined metallic roughness ambient occlusion texture. Ooh, I almost did a no-no here. That's why copy pasta can be dangerous sometimes. Okay, so this one needs to be MRA pixels. And then we need the default, default MRA texture name. Like 10 times more productive on red than I am on GDB. Yeah, and that's why I want to give it a shot, right? But I kind of want to go into it blind. I don't want to sort of get used to it on Windows or something until the Linux layer is also finished, in case he has to change some of the stuff and how it works. But yeah, I'm definitely looking forward to switching to that. And hopefully, I'm hoping he decides to also support Mac on it. Let's see. How long did it take you to get decent at using Vim NeoVim? So from the time that I actually installed it on my work machine and used it daily, drove it from work, like I did. Okay. So I did the Vim tutor thing for a week, every day for a week, twice a day, just to get used to like some of the basic motions and stuff. Then I installed it on my work machine at the time and used that every day and forced myself to use it as well as here, right? So from the time that I did that up until the time that I would say I was reasonably fast with it, or just as fast as using this one, was about a month and a half, give or take. And I mean, I've been learning stuff, like I'm still constantly learning stuff about it. So I don't even consider like myself an expert at it now. I'm definitely not, but I'm definitely faster with this than any other editor. And I've been using it for a few years now, but yeah. The only MS debugger that I'm used to is VS. You're talking full-blown Visual Studio. Yeah. I stopped using that years ago, except when I have to for like work-related stuff, because it is a bloated, huge monster. Tried GF2, a GDB front end. So I actually have tried GF2. And it's not bad, right? But it's not quite as intuitive and quick to use as this guy. It just isn't. But maybe it will be if I get a better understanding of GDB. Unintuitive and hard to wield, but a must learn for any kind of Windows exploitation. Use it for debugging programs written. Had source code for its sort of similar experience as GDB, but not too similar. You're referring to WinDebug or WinDBG. Gotcha. Okay. Yeah, I've never used that one either, but okay. All right. I guess that makes sense. All right. So we just got a couple minutes here, so I'm just going to kind of try and finish up. I'm going to try and finish up at least these default textures. All right, so cube texture. So actually, cube texture gets a little bit interesting because, oh, and this is actually making me think of some stuff that I've missed. Specifically this. Let me go to texture cube map acquire. Because I think, do we automatically set the layer count in here? Actually, I think we do. I might be good on that. I might not have to do that. Yeah, I think we do. Okay. I was thinking, because here we actually have to pass in the number of layers we have, and I was thinking that might be a problem, but I think I can actually still use pixel data. Maybe not, actually. Because pixel data makes the assumption of 2D. So what I should actually have is texture cube map acquire from pixel data, right? And literally the only difference here is going to be that, right? And I guess we could also set the depth or whatever, but we don't actually have to do that because this determines that for us. So I guess let's go here. Let's add this to the header. Right. And let's do this equals texture cube map acquire from pixel data, right? And so the pixel format again is going to be RGBA 8. The pixel array size is right there. Pixels is going to be just pixels. And then width, I think, is this a 16 by 16? Yeah, it is. Okay, so 16 by 16. And then default cube texture name. All right, and then we can delete that line. Perfect. All right, so that's our cube map texture. Now, this was something that we had discussed when we talked about layered textures for like terrains, which is why we have a fix me in here for this. So that is not going to be considered part of this change set, because we actually have to implement I guess what we could call multi-materials or blended materials. And blended materials are actually what's going to need this. So that's going to be part of a completely different change set, so I'm not going to implement that here for now. Now, we also have texture acquire, and we want to do, this is for the default normal texture. We actually want to do texture acquire sync here, because the system actually relies on this, right? So when we're standing up the texture system during engine boot, right? We actually want to use the synchronous version of this, right? And we're going to use the default package, which no longer requires this stuff or this stuff, right? It's just, in fact, it's actually just this. So we don't need the K name anymore. We don't need any of that stuff, right? We just load these synchronously from disk. And that is going to give us everything that we need during startup. This is one of the few examples of where we want to use the synchronous version of this, so we'll exercise that portion of code as well. Let's see. So, that being said, we do have lots more code to delete. But let's see. Release generation, this can go away. Invalidate texture, we don't need that anymore either. And then we've got some more request things down here. Oh, and then this is just our new stuff. So actually, writable array, we actually don't need this. We can re-implement that using our options function, so we don't need that either. Default texture by name. We should probably keep that one. And we should probably keep this. So let's do texture release. Right, so actually that's going to be texture release. And then we actually don't need that that state pointer. All we need is actually just these all the way down. And that's that. So this is no longer old or to be removed either. That is part of our shutdown process to make sure that we release all textures. And then the only other thing we have in here is default texture by name. So default texture by name, are we actually even using that? The only place it's referenced is in this file. So, see ya. Okay. So that means both of those can go as well. Okay. And these can go. Did that still exist? This doesn't actually need. Yeah, it does need state. Okay. Is default texture. I don't think we need that either. Nope. Okay. These are the old functions. We do need those two though. So we can actually take those and put those here. And I believe, other than some of the other obvious stuff that is warnings and errors and stuff, I think we're actually good to go. Let me actually just flip over here to the header file real quick and get rid of all the stuff at the bottom of this. So I think, yeah, we don't need that. We don't need this. Okay. I do want to keep some of these comments though, because like I did go through and actually nicely comment this stuff, and I want to move them up here, but I'm out of time for tonight. So, what I'm going to do is I'm going to put a pin in it right here. But in this file, we only have 15 errors left, and that is mostly just because we have to delete these old functions. And then in the C file, we only have 9 errors left, down from 200. So I think that's pretty good. All right. So that is going to do it for tonight. I really appreciate you guys being here, and I appreciate all the follows. If you haven't followed me already, I would ask that you do, either here on the Twitch side or over here on the YouTube side. It helps me out growing the channel and stuff, and I really appreciate it. Let me go ahead and find somebody to raid who's doing something kind of similar as to what we're doing. Let me actually scroll through the old list here for a second. Let me see. Let me check one thing really fast before I do. So I think what we might do is let's see, he's on Be Right Back, so let's do, you know who we haven't rated in a while? We haven't rated, oh wait a minute. Let's raid Hypnotic Games. He's a cool dude. He's using Godot to make a game. Let's go check out and see what he's up to. Anyways, guys, that's going to do it for tonight's stream. We should be back tomorrow, right here, hopefully a little earlier tomorrow. We got kind of a late start tonight, but yeah, thank you guys so much for being here. I really appreciate it. And yeah, I will see you guys on the next one. See ya.